No computer. Okay. So what I'm going to do is I'm going to start. Usually you do this with 2 hand weights, but I use this because it gets more of the mass further from the axis of rotation, and the distance actually goes like the distance squared from the axis of rotation. So this should be enough to make me get sick and vomit when I rotate, which is an awful thing. Okay. I want to slow down. That went a little too well. Usually I fall off over here. I wanted to just note that a helicopter has a propeller that spins around. It has another propeller on the back that rotates like this. The one that rotates like this, when he turns it on, this guy has to be rotating, or else the helicopter, when it spins the propeller one way, the helicopter will spin the other way. Action movies, you can see what happens when you knock out one of these. So both of them are needed. This one's needed for stability. There's an advanced helicopter that's been built with 2 rotors, one of which rotates this way, one of which rotates this way. So the rotational motion is canceled. You no longer need the tail rotor for stabilization, and so they push backwards. And so we can get a higher velocity on the helicopter. Okay. Okay, we're up to energy now. So far I've talked about pushes. If you have a push acting on something over a certain distance, it will make its energy of motion change. In other words, if I have an object sitting right here, it's at rest, it has no energy of motion. If I throw it with some speed, it has a certain energy of motion. Okay? If I simply hold this guy at a certain height, and I let go of him, he has no energy of motion now, but when he hits the floor, he has energy of motion. That meant that when I was holding him up here, he had a potential energy, because you can change this potential energy of position into energy of motion anytime you want, just by letting go of him and having gravity take over and go downward. Okay, well, another way you can do this is with a pendulum, where you go from up here potential energy at one place to energy of motion at the bottom, and then it swings up to potential energy again, and it goes like that very nicely. And usually when we explain this to the students, we haven't endangered the professor, so they're not happy. So we had a bit of an accident on this one last night.
Do you want to put it right there first?
Yes, since I explained it. Sometimes when I do this in lecture, I'm on my own, and I have visions of me climbing up this ladder with this weight and losing my balance and falling off the ladder, and then getting up off the floor and have the thing hit me as it spins down. It'd be a shame not to have a video of that. It would now be very popular on the web. Now, just to illustrate this, you can see a picture of a brick down there, and I'm going to change the energy of motion essentially into energy of destruction, or so there is a great deal of energy in this guy. You know, it's good not to come late to my class either. You can walk in the door and be hit by somebody coming flying through. We're all clear on the other end, right? Fire in the hole. Okay, so now what I'm going to do is I'm going to start this thing on my nose. This is putting your money where your mouth is. And I don't even have to take my glasses off, because I know if it ever gets back to this same height, its energy will be all potential energy. No energy of motion. No energy of smashing noses. And I'm very confident of this. Very, very confident. Almost confident. And that's with the spring. If I have a spring, well, a spring has a certain potential energy. You know, if you want to exercise with it, you can pull it like this, and you have to put a force on it. And if you go like this, you get chest hairs caught and things like that. But if I stretch it, it has a potential energy because it's been stretched. And if I hang it like this, and I press it together, it also has a potential energy because it's been compressed. So if I pull this guy down here like this and let go of him, he will go from just potential energy to at the place he likes to hang when he's at rest to all energy of motion to potential energy, and he'll trade potential energy and energy of motion back and forth over and over and over again. Okay? And if I want to make him really go wild, instead of just giving him a kick like this, what I do is I wiggle my hand at the same frequency in which he likes to wiggle. I say, okay, he likes to go 1, 2, okay, so I'll do it like this. The energy I put in each time builds up and the thing will eventually shake itself apart. You can do this with a pendulum. When you're the pendulum bob, you sit on a swing. And if you lean back at the same part of your swing each time, your swing gets a little larger, and it gets larger and larger. If it gets large enough, you go over the top and go home and have a day off. Which one are we up to?
We can do the resonance of our...
Ah, yes, yes. This driving something at just the rate it likes to ring. Where's the wine glass? Thank you. I always need help when I'm around. If you tickle a wine glass, it will ring at the resonant frequency it likes to wiggle at. This is a good one you can do when your parents take you out to a fine French restaurant. I always wondered why my parents stopped taking me out to dinner. At any rate, this guy rings at just a nice resonant frequency, a frequency at which he likes to vibrate. And if I could somehow vibrate him at just that right frequency, in fact, I could make this guy sort of fly apart. Now, Dave does all the hard stuff here, and he's going to tell you about doing that same trick.
What we have here is just a beaker, okay? And before everybody showed up, once again, we set something up, and I found out the resonance frequency of our beaker. You can see the beaker right behind us right here, okay? And what we're going to do is we're going to look at the waveform of this beaker as I actually get it excited.